Awesome. All right. Good morning, everybody. Today is July 20th. I can't believe that we're already in July. This is wild. And this is the CAPN office hours call. We're taking a couple weeks off of actually, or at least 1 week off of meeting. And yeah, this will be posted to YouTube after. So don't say anything you don't want there, and follow community guidelines. To get us started, we have nothing on the agenda, just a bunch of fun faces in the Zoom channel. Does anybody want to just bring anything up and talk about anything?
Yeah. Hi, Chris.
Hey.
Yeah. So I just submitted the CAEP, the enhancement proposal. Yeah, you wrote, and I add some of the implementation details. So this CAEP, we will focus on how to template the control plan using the KCP provider, the kubeadmin control plan provider, and you also use the kubeadmin library from the Kubernetes modular to make it more CAPI way, in a more CAPI way to creating a control plan. So I add some of the general process of how we are going to templating the control plan, and also add some implementation details. I think Vincent and Scott, you guys are expert of the CAPI and also very familiar with the kubeadmin. So if you guys can help us to review the proposal, that'll be great, because I'm still not sure if we are doing it in the right way. Yeah.
Awesome. Do you want to walk through it? Do you want everybody to read it before we spend the time doing that? How do you want to handle this?
Yeah, I think I can go through the proposal, since we do not have anything we wanted to discuss for now in the documentation. So I think I can go through the proposal very quickly, and if there is something wrong, and Vincent and Scott can give us some suggestion. That's what I think.
Sounds great. I have just made you co-host, so you should be able to present the doc and
sure.
talk through it.
Okay.
Thanks for doing all this.
Let me just open up the proposal and share the screen.
For background, Vince, we've been talking about that long-term pipe dream that we've always had about getting closer and closer to actual CAPI core types. And so Charles has been spearheading that for a hot minute, and this is basically the beginning docs of that. Charles and I have both talked about two pieces to this as well, doing it in two phases. So I believe, and Charles, correct me if I'm wrong, but this is basically the first implementation would be really focusing on just KCP to help augment what we've done currently with the control plane provider. So in essence, removing the nested CRs so that we can actually get towards pulling the static manifest from KCP. And then a secondary piece that we still haven't written the doc on is going to be about how to integrate machines into it to really have the more CAPI integration piece.
Yeah, I just noticed that my Zoom does not have the permission to access my crown, so I need to restart a Zoom, or maybe you can open the documentation.
I'll happily open it. Just give me 1 second to share.
Sure.
And
it should be inside the PR. Yeah, the pull request.
Everybody see Chrome? Yeah. Okay, cool. You want to talk through this? I'm going to see if I can move it over to a different window.
Yeah, sure. So as Chris just mentioned, so we wanted to make because right now we are using 3 nested CRD to actually create, when we are trying to provisioning the nested control plan, we are using 3 nested CRD, nested API server, etcd, and a control manager to reconcile and actually create the components. But I think it's not in a real CAPI way, because when I check the CAPI implementation, like the Docker provider, we are actually using the machine CRD, using the infrastructure CRD, and some other like kubeadmin control plan provider. So I discussed with Chris. So and we think we should move onto that direction. We should try to implement the whole provisioning process using some existing CAPI concepts and the CRD. So that's why we come up with this this proposal. And we are going to have another proposal just for this proposal will just focus on how we are going to templating the control plane. And for templating, that means we are going to create each control plane component using stateful sets. And inside the stateful set, we will have the part templates. And we wanted to use the standard kubeadmin library to generate the part spec for us, so that can make our control plane more close to the upstream Kubernetes. And also we will have another proposal for describing how the nested machine controller are going to use those templates to actually create the nested control plane components. And in this proposal, we will just focus on how we are going to use the kubeadmin library to extract the static part templates and generate a stateful set. Yeah. And Chris, could you help me to scroll down a little bit? I wanted to go to the, I think it's the not implementation detail, the proposal section.
Is this the right spot?
I'm still,
Or
I think we are still in a summary section.
oh, hold on one second. Something's going on because I must be looking at something completely different. Share screen one more time on this thing. That's what you're looking for.
Yeah, correct.
Okay, cool.
Yeah, so that's the proposal for how we are going to template the control plane. So there may be some mistake. If I made admin mistake, Scott and Vince, just feel free to interrupt me. So our final goal is we wanted to leverage the kubeadmin control plane provider. So I investigated the Docker provider, and I think we can do something like this way. So here is the flow diagram, and I will go through the diagram step by step. So first, I will we are going to assume the user are going to apply the kubeadmin control plane CR and all other necessary CAPI CRs. And then the KCP controller, the kubeadmin control plane controller, will keep checking if the nested cluster CR is ready, if the infrastructure is ready. If the infrastructure is ready, the KCP controller will adopt some desired number of nested machines from the nested cluster infrastructure, which is specified by the users. And then the KCP controller will generate the kubeadmin CR based on a KCP created in the first step. So in the first step, we create a kubeadmin control plane, and inside that kubeadmin control plane, we will specify the something like the kubeadmin config for provisioning the control plane for the kubeadmin. So in the step 5, we will assign this. So we will create a kubeadmin config CR. And we will assign this kubeadmin config CR to a specific nested machine CR by setting an object reference. So inside the nested machine CR, we're going to set in an object reference, which will point to the kubeadmin config we just created. And then in the step 6, the nested machine controller will keep checking if the kubeadmin config has been assigned to it. If the nested machine controller finds there is available kubeadmin config, then it will call the function from a kubeadmin package, which is we will import it from a Kubernetes modular. I know it's not recommended, but since we wanted to reuse some function from the kubeadmin package, we have to do it. And then we will call the function inside the kubeadmin package and generate a static part templates. And finally, the nested machine controller will extract the part templates from a static part template and generate, I think there is some typo here. Anyway, we're going to generate the stateful set template, and then we will use this stateful set template to create the nested control plane components. So that's the general process of templating the nested control plane. Do you guys see any mistake or misunderstanding?
So from my perspective, I know I'm only confused about adopting nested machine. KCP will actually go and create nested machines from a nested machine template CRD, which you would have to offer. as part of your CRD
I see.
list. So the control planes are actually created one by one. One challenge that you probably get into is the health checking part of it, where like the KCP will try to go and actually look and connect to etcd, which, because like it will assume that etcd is spinning up like on the host itself. So you have to do some magic there to like either say that etcd is external and so avoid those code path, or figure something out that like you can actually still let KCP connect to etcd and run those health checks. The other thing about kubeadm, importing kubeadm, like you mentioned, like it's not supported. I would actually suggest to copy those function, not even joking, but actually just copy the code and just put it in a third-party repo. That's how we do it in Cluster API. The reason for that is because we're actually exploring to how to create like a kubeadm library, so like the staging repo, etc. over time. It's not staffed to work, so like it would require some folks like to step in and do the actual work, but we'll see like how that goes over time. Overall though, the plan looks fine to me apart from the adoption pieces. Yeah, so KCP will actually go from the template, clone the template, and actually create machines one by one.
Okay.
And then you
KCP.
can just react
Gotcha.
to that creation and create your own objects underneath it.
I see. Oh, okay. So to be more clear, so we need to create something like nested machine templates that need to be applied by end users. And then the KCP will use these templates to create the actual machine. Is that correct?
Yes.
Okay.
Yeah. So I don't know if you have like a nested machine template already.
No, we do not have. Yeah.
Okay. Yeah. I mean, you probably definitely want to have it, like, especially if you want to use machine deployments. You need that to create machine deployments.
So do we need to change the source code of maybe the machine deployment or KCP if we wanted to add new machine templates?
No, you just configure KCP machine template infrastructure reference to be the template.
Okay. Got you. Yeah, that makes sense. Yeah, but that part, what Vincent just mentioned, will be, I think we will put it into the nested machine proposal. What do you think, Chris?
Yeah, I think so. Although this will be interesting. So potentially maybe I wonder if we can think about this slightly different for this first iteration and just take, instead of even doing machines within this, basically take the controllers that we already have for nested API server controller manager and what have you, and just implement those functions to generate the manifest in that. And then at least we have the code pulled out already. And then we start to go and define the machine template, so on and so forth pieces as the secondary piece. So we basically do templating, replace our current templating, which I don't think anybody's really stoked with. And so move from that to KCP based so that you could at least supply the standard types. And then we go and then we start to create those resources separate. And that helps to draw a little bit of a delineation. And then in essence, correct me if I'm wrong there, but in essence, like machines at that point are just replacing the component controllers. And it's just a conversion of those that controller code into another controller in CR, right?
Correct. Okay. Yeah, that makes sense. So that's what I think as well. So I put it into the implementation details. So for the PR for this corresponding to this KEP, we are going to reuse existing implementation, and we are just going to mimic the whole process by creating a kubeadmin config CR manually, and then try to generate all these templates and still using the existing controller to create the control plane components. Yeah, that's my plan. Yeah.
Perfect. Sorry, I hadn't actually read the whole doc yet. So awesome.
Yeah,
I think
okay.
I think this is perfect.
Okay, good. Yeah, I think that's the main story of this proposal. And about the health check, I have some question because Benson just talked about the health check. So I remember Scott said if we set the name of the stateful set in a certain format, the KCP controller will actually will be able to access this machine or this stateful set or these pods, right? Will that help us to achieve the health check? Help us to do the health check?
The idea of the stateful sets was that you can have a predictable name that then you could use in order to basically configure the pods within the nested cluster that could match up with the machine names. Because it goes, the components go according to the machine name. So if you use a stateful set, you can get deterministic names, which could then be utilized in that way, kind of as a way of, working around that necessity, possibly, was the idea. Okay.
So the naming convention is actually not going to help us to do the health check, right? We are still need to have some like IP address or other things we can use to let the KCP controller to visit the etcd and an API server to do the health check, right?
We basically need to register machines or nodes into the clusters and bind fake control plane pods into the cluster, so that then it could yeah. So like how the VC syncer syncs a pod and then creates the binding with the node. We in essence need to like hack that so that we have an additional piece that goes and creates a node object in the cluster that has the right references, so that it can then so that KCP can call through the kubectl client in essence, or client Go in essence, to go do exec against those things.
Great. Okay, got you.
Which I think we have two parts that we can think about, two different implementations that we can think about there. We can think about extending VC syncer to have an additional like flag that this is automatically added into, and we do upward syncing specifically in like a specific namespace. Like if we created these components if we pre-created, instead of where VC syncer right now, if the VC manager, how it currently creates the control plane namespace as like the prefix plus cluster name, and it's just based like that, and it doesn't have the nested namespace. If we change that to then deploy into the cube system namespace, that's like pre-create the cube system namespace, and then we could potentially do like an upward syncing for those pods specifically from that namespace, like treat that as like a special namespace where we grab the pod that's scheduled in the super cluster, sync it back into the tenant control plane, and then sync up the node object that goes along with it, which might be the most simple way to do it. Otherwise, we could mock the object and pre-create it mapping to different namespaces in the tenant control plane. Either way, I think could work.
Got you. Yeah, but I think this implementation requires us to tightly coupled with the syncer component, right? Do you think that will be a concern? I may prefer like we can use our like in the Kappan, like the Kappan controller to complete all this process, and it can be loosely coupled with the syncer controller.
Yeah, I agree.
I think some user may want to just use it to not using virtual machine or using syncer. They just wanted to use Kappan to provision some control plane. Do you think that can be a potential use case?
Yeah, I think so. We could probably also just run the syncer component as we could basically have VC syncer. We could have like Kappan syncer that you can deploy or not deploy. Like you can choose as a user to deploy it, and then you have the Kappan control plane stuff. Like currently, hold me honest here, but like Kappa, so the AWS provider has like a separate cluster cuddle that they go and use to install specific components that like an additional component beyond their base infrastructure control plane provider. And so we could in essence do something similar to that, where we have, you're going to be deploying Kappan with VC, do it this way and deploy this additional controller. that's separate from VC, but also separate from CAPN or core CAPN if you don't need it.
Okay.
That makes
Got you.
sense.
Yeah.
There's a lot of pieces.
Yeah,
there.
we can discuss it later. Yeah, it make things a little bit complicated, but I prefer this way. Yeah, make things independent from each other. Yeah.
Yeah, because in theory, if we don't have this, if we don't force that support, in theory, there's always the way that folks could use this to just create control planes, hook up nodes outside of the cluster, and it doesn't really matter. And it's just a completely different story that we wanted, that I think we wanted to support potentially for workloads.
Right.
So.
Yeah, totally. Yeah. Okay. So I'm going to revise this proposal based on Vincent's suggestion, and I'm also going to I'm still working on the implementation. So it looks like we will have some more extra things we need to do, because we need to copy the kubeadmin libraries from the Kubernetes modular to our CAPN repository. So I will keep working on these implementations, and if there is anything ready to review, I'll submit a PR. Yeah, that's all from my side.
Awesome. Thank you for doing this. This is really cool. I'm excited to see this. And this I feel like is a good alignment back towards other CAPI implementations. So nice work.
Yeah. Okay. Thank you.
All right. What else can we talk about? Anything else anybody wants to bring up? I'll just a status update. I still have yet to get back to CAPN. I've taken a little bit of a break to do internal stuff. So I haven't gotten a chance to actually go start doing releases for the VC components. That's still on my plate. I'm still hoping to eventually get to it. I don't know what my timeline is going to look like for the next week, though. It potentially is next week.
Yeah, I have a question for Kubernetes type of the provision. How that handle the upgrade? Because we were talking about this for a long time. So, so it seems like we are going to use the CAPI upgrade workflow if we do that way. Is this the plan?
I have not investigated the upgrade yet, but I think I will first try to implement the provisioning process, and then I will visit to the. Yeah.
Yeah, I'm just curious since Vince is here. So how does CAPI upgrade? So is upgrade the whole cluster or component based?
Copy with regards to the control plane, so KCP, like when you do like a version upgrade, so like you just change the version number. Right now, assuming that the images are in the cloud provider, it will go into each machine, like create a new one with the new version, check it out, everything is okay, and then delete the old one. And it's gonna do it for each one of them until like the spec matches the desired state. So that's how upgrade happened today.
Oh,
so
for the machine, even for doing the Kubernetes rolling upgrade first, is this what you're talking about? So why do you need to create a machine?
Because everything is immutable. We don't touch the machine after it has been created. So we create the new one with all the new configuration and components, and then delete the old one.
The new machine has everything, but including API server, control plane, Okay, the
Correct.
New machine with the new static paths with all the new versions. Let's switch to that machine.
Yeah, correct. What KCP does extra is to also upgrade kubeproxy and core DNS after the control plane has been upgraded. So there's also that.
So is that controllable?
Yeah, you can annotate it and say like, I don't do this.
Perfect.
So, but for the control plane, is the version fully configurable or is templating? So it's all based on templating, or user can specify specific versions for each one. Like say, at CD version, I use the old version, but API server I use the 122, something like that.
You could. We strongly suggest that you keep things in sync. This like with what Kubernetes has validated. So like usually like if you just leave that empty, we'll like upgrade because Kubernetes has upgraded, and not because we have chosen explicitly to upgrade. This way we don't have to like maintain like, you know, crazy compatibility matrices like around.
Yeah.
So we'll defer that to kubeadm. So you will have to do like something similar, I guess, like in nested. But I think like like if you have the nested machine concept, that it then creates the stateful set like on the underneath it, and then like attaches owner references. When you create a new one, you just spin up the new versions and delete the old one, and we'll tear down the old versions. What is cool about KCP is that it will make sure that, for example, the etcd member has joined, there is no alarms on etcd, the control plane is like, you know, in a ready state and everything. So it will do the proper health checks to make sure that nothing will be messed up. You can also configure it. So you could actually say, I want to, I don't want to do a rolling update to create a new one. You want to, maybe, I don't know why you would want to delete first and then create a new one. This is usually used for bare metal, but for pod-based control plane, I don't think like you would want to do that. But I want to create the new ones first.
Yeah, I think I'm just going to throw out my 2 cents on this is to make that machine lifecycle stuff a little bit easier. My hope is that we actually don't do stateful sets at that point, and we switch over to using the static pod templates and just let KCP entirely manage them and not have to think about converting pod templates over. First implementation, I think it's a good idea to basically convert those pod templates into stateful sets, because we're not going to have the rest of it, and we're just re-implementing how templating happens. But then once we have machines, we can create a machine. It goes and creates the 3 components that go along with that component, or with that cluster, with that machine, and that like becomes a faked machine in the cluster that you could then operate on. And then we can do all of the life cycle there. So we create a new machine, do the exact same thing. It deploys into whatever namespace it needs to, gets synced into your cluster, however that actually looks, the hand wavy bits there. And it just feels like a traditional cluster in that regard.
Yeah.
And that also gives us the predictable namespace, or the predictable names that we just need to bind fake nodes, virtual nodes to map to those names.
Yeah, it seems like we just need a fake node, basically fake machine. It just doesn't exist at all. Just has an object to mark the upper controller. Then we can reuse everything I think it's okay to create a new fake machine to completely switch during upgrade. If that is already the workflow, so I'm okay with it. Yeah, because if we stick to stable set, I think the upgrade code needs to be changed, because there's no such implementation for upgrade the stable set anyway. You have to. Yeah, that's okay. I just want to understand. So if that is the final picture, then because so Chris knows people start to ask about the upgrade workflow in the GitHub issue already. So we better prepare to see what exactly the future milestone or future implementation would look like.
Yeah, that's my hope for the upgrade strategy. So we get to that and we basically just purely align the control plane aspects. It'll be there's like 2 parts to this that I don't think we've fully talked about as well, which is like how exactly cluster cuddle integrates into some of these things. I think they're a little bit implementation details, but I think they're interesting. At least like when you do cluster cuddle and you say create or what is it, generate template, you can supply things like how many control plane nodes you want. And that then translates into, correct me if I'm wrong, Vince, but like that directly translates into what the machine templating converts into multiple machines downstream, correct? And so we need to like figure out how that all those pieces will wire together. Like just subtle implementation details. I'm just going to be quiet.
Cluster cuddle?
Yeah.
Yeah, we don't have to use that, but like if you use KCP, it's like already built in, you know?
Yeah. I mean, basically my goal is to basically support everything we can possibly support out of KCP that's possible. And from what I've heard and in our conversation, it doesn't seem like there's anything that's really going to stop us from being able to fake a machine to make it still feel natural. Because you're not doing any, like my big concerns would be you SSH'd into an actual physical machine from Cappy's control planes, then we're screwed. Like that's like a no op for us. But as long as everything's through client Go or the Kubernetes client, we should be good.
Yeah, with an SSH, the only thing that we do is to connect to etcd via kubectl proxy, or client go proxy. Pretty much.
Yeah, that's perfect. And V5 things, do we need to start? There's conversations happening, or V1 Alpha 5 already for that, or are there things that we should be aware of that are potentially going to get in our way? I know we've chatted about this before, like the node bootstrapping changes that's happening. Do you see any of that conflicting with anything we've talked about so far?
No, no. So like the Alpha 5 is not going to be super soon. Like right now, one of the main focuses, at least from VMware side, is going to be cluster class. That could actually be really useful for like your things, especially when we talk about like a dynamically template within a controller. So like all the templating engine and cluster class will remain, but like we'll try to make like the templating story like much better with cluster class. And yeah, like I'll definitely, like once you implement KCP, like take a look at cluster class and make sure that it fits your needs, etc.
FYI, I just dropped the link into the Zoom chat for that proposal that's on the CAPI side of things. And I'll also add it to our agenda in case folks want to review that. Yeah, thanks for calling that out. It's a good piece for us to remember. Cool, folks. I just want to also say super amazing job, everybody that's been supporting CAPN. We've had a big uptick in people actually being active in it. Well, that NVC specifically. So I don't know about you all, but I'm pretty stoked about that. And seeing more contributors from other companies makes me just very ecstatic. So good job supporting everybody, and let's keep it up because this is great. And I hope that we can eventually get some of those folks to join this, although time zones are probably our biggest mess there. All right, y'all. Anything else?
Yeah, I don't have.
Awesome. It was fantastic hanging out with all of you. Again, recording will be posted to YouTube. I'll get this up and probably by the end of the day. And y'all have a great rest of the week. And I'll see all of your wonderful faces next week. Bye.
Bye.